module 5 നമ്മൾ greedy approach. Okay, in the module 5 we want to study the greedy approach. Okay, so what is greedy approach? So this is greedy approach or algorithm. Okay. So in the module 5, in the first part of the module 5, we want to discuss greedy approach. Okay, greedy approach. In the module 4, we discussed divide and conquer approach, dynamic programming approach. Then in the module 5, we want to discuss greedy approach of the first part. We are basically we are studying different approaches of problem solving. Okay. Each approach is suitable for some particular type of problems. Okay, so divide and conquer approach is suitable for some type of problem. Then dynamic programming is suitable for another set of problem. Then greedy approach is suitable for another type of problem. Okay, so now we are discussing greedy approach or greedy algorithm. Okay. So okay, good morning. Okay, please give your attendance now. Akash, give it in the chat box. Okay. Okay. Now we are discussing greedy approach. So okay, so what is greedy approach? It is used to find solutions to complex optimization problem. Okay, so the first point you should be noted is that the greedy approach is suitable for solving complex optimization problems. Okay. Complex optimization problems. So what is optimization problem? Okay. We need to get the optimal solution. Okay. That type of problems is called optimization problems. So different type of problems that can be solved using greedy approaches are given below. Okay, so there are different problems. There are some type of problems that can be solved using greedy approach. Okay, not all problems can be solved using the greedy approach. There exists some type of problems that can be solved using greedy approach. Okay, so basically those problems are optimization problems. Okay, those are optimization problems, and this include knapsack problem. Okay, this we want to study. This is basically 0 bar 1. There are two types of knapsack problem. One knapsack problem and another is fractional knapsack problem. Okay. Then job sequencing problem, Huffman coding, shortest path finding problem. Then TSP. What is TSP? TSP means traveling salesperson problem. These problems can be solved using, it is possible to solve this problem using the greedy approach. Okay. These are some particular type of problems, okay, that can be solved using the greedy approach. So next In certain cases, greedy algorithm gives optimal result. Okay. If we solved the above problem using the greedy approach, it will give the optimal. It will give the optimal result or optimum result. It's the best result. It will give the best result. So next, so what type of problems we can solve using greedy algorithm? That we want to discuss next. I told already it is suitable for solving some particular type of problems. Okay. Okay. It is suitable for solving particular type of problem. So my question here is, what type of problems can be solved using greedy algorithm? Okay. You cannot hear particular type. Okay. Greedy algorithm is used to solve a particular type of problem. The nature of the problem will be like this. Okay. So most of this problem, this is very important. It is used to solve a particular type of problem. Most of this problem, the problem characteristic is most of these problems have n inputs. Okay, n inputs, and we are required to obtain a subset of n, a subset of n that satisfies some constraints. Okay, that satisfies some constraints. For example, so most of these problems have n inputs, and we are requested to, there are n inputs, we are requested to find a subset of n that satisfies some constraints. This type of problem can be solved using greedy algorithm. I'm going to the TSP case. Okay, traveling salesperson program. Okay, so what is TSP? TSP or traveling salesperson program. For example, there exist 5 cities A, B, C, D, E. A, B, C, D, E. And there exists a path between them. Each path having a weight. Okay. Each path having a weight. So starting from city A, a salesperson starts its journey. Or starting from city A, salesman must travel to all cities exactly once before returning to A. This is the constraint of this problem. That is, starting from city a salesman or salesperson travel should visit all cities, okay, exactly once and return to A. So he should visit all cities A, B, C, D, E exactly once, and he should return back to A. Okay, this is a problem. And in this problem, this is the constraint. Okay, that is, this is the constraint. Salesman must travel to all cities exactly once before returning to A. Before returning to A. This is a constraint of this problem. So, in addition, subjecting to the objective function. There is a constraint and there is an objective function also. Okay. Subjecting to the objective function, the total distance traveled should be minimum. So the total distance traveled should be minimum. This is the objective function of that problem. So if you consider this problem, there are two things. Okay, first thing is uh, there are some constraints to achieve a task. That constraints should be satisfied, and additionally there is an objective function. That objective function also should be satisfied. So in this case, TSP problem, starting from city A, salesman must travel to all cities exactly once before returning to A. This is the constraint of this problem. Okay, a solution should satisfy this. Additionally, the solution should satisfy, subjecting to the objective function, the total distance traveled should be minimum. This also should be satisfied. That is, there exists an objective function that should be maximized or minimized. So in this case, we are defining what is a feasible solution. Okay, in this case, what we are defining feasible solution. What is a feasible solution? Any subset of solution that satisfies these constraints is called a feasible solution. So if you consider this problem, there exists a constraint. Okay, there in this type of problem, there will be a constraint. If a solution that satisfies that constraint, that is called a feasible solution. Okay, any subset of solution, there may be more than one solution that satisfies this constraint. This is called a feasible solution. So in this case, you can observe these are different solutions. Okay, these are different solutions. For example, a salesperson can start from A and he can visit B, then C, then E, then D, then A. Okay, then the total cost is 20. Okay, so this is one solution. All cities are visited exactly once and he reached back and the total cost is 20. Okay, so next is A, C. He start from A, C, B, E, D, A. Okay, he visited all cities exactly once and reached back A. That is, the constraint is satisfied. Okay, the total cost is 26. Okay, another is he's starting from here, he visiting D, E, C, B, A, and he is returning back to A. So the constraint is satisfied. The total cost is 20. Another is this one. Okay, that is, this is one solution, this is another solution, this is another solution, this is another solution. There exist 4 solutions that satisfies the constraint. Okay, that satisfies the constraint. What is the constraint? What is the constraint here? What I mean, I'm writing just C. C means constraint. What is the constraint here? What is the constraint? This is the constraint in this problem. A salesman must travel to all cities exactly one before returning to A. So this is the constraint. There exist multiple solutions that satisfies this constraint. These are called a set of feasible solutions. Okay, but we need to find an optimal solution from this. So now we are discussing another term. What is an optimal solution? What is an optimal solution means? Optimal solution means a feasible solution that maximize or minimize the objective function. Okay, so what is an optimal solution? Please note, what is an optimal solution? A feasible solution that it is a feasible solution, that is any of this. Additionally, that should maximize or minimize the objective function. Additionally, that should maximize or minimize the objective function in that problem. That is called an optimal solution. That is called an optimal solution. For example, in this case, A, B, C, E, D, A. This is a solution that satisfies the constraint. And the total cost taken is 20. This is the objective function. Then from this set of solutions, this is the minimum cost solution. So this will be the optimal solution. Okay. So in that case, this is the optimal solution. Why? Because the total cost is minimum in this case. Okay. So this is about the optimal solution. So basically, this type of problems can be solved by using the greedy approach. This type of problems can be solved using greedy approach. Okay. So this is an example of problem that can be solved using greedy approach. I'm repeating one more time. So what is greedy? What is the use of greedy algorithm means? It is used to solve, it is used to get optimum result for some particular type of problem. Okay. So next is that problem should have n inputs. That should have n inputs. And we are required to obtain a subset of n. A subset of n that satisfies some constraints. That satisfies some constraints. That satisfies some constraints. In addition, we need to get the optimal solution from that. We need to get the optimal solution from that. That type of problem can be solved using greedy algorithm. For example, TSP problem. In the case of a TSP, this is the problem. Starting from city A, salesman must travel to all cities exactly once before returning to A. So this is the constraint on that problem. Additionally, that problem should satisfy this also. Subjecting to the objective function, the total distance traveled should be minimum. So in this case, what will be the feasible solution? What is the feasible solution is here? Any subset of solution that satisfies the constraints is called a feasible solution. But what is an optimal solution? A feasible solution that maximizes or minimizes the objective function is called an optimal solution. So we need to find the solution. We need to get an optimal solution. Okay. We want to get an optimal solution that satisfies all the constraints. So this type of problem can be solved using greedy approach or greedy algorithm. For example, a knapsack problem, fractional knapsack, a job sequencing, a Huffman coding, a shortest path, a TSP, all are this type of problem. That is, each problem having some constraints. Additionally, there will be an objective function. That objective function should be maximized or minimized. So that type of problem can be solved using the greedy approach. Next, best example is TSP. TSP. Okay. So next, what should be the greedy approach? Okay. It works in stages. This is the greedy approach. It works in stages. Okay. Each stage consider one input at a time. There are n inputs. Each stage consider one input at a time. Then at each stage, a decision is made regarding particular input is optimal or not. Then at each stage, it works in stages. Okay, it works in stages. Each stage consider one input at a time. One input at a time. Then at each stage, a decision is made regarding particular input is particular selected input. Particular selected input is optimal solution or not. If it is an optimal solution, by using some method, it will check whether the selected solution is optimal solution or not. If it is an optimal solution, then what we will do? It will be added to the partial solution set. It will be added to the partial solution set or partially constructed optimal solution. Then in the next step, what we will do, if the inclusion of the input into the partially constructed optimal solution result in an infeasible solution, then what we will do is that we will first add that optimal solution to our solution set. Then we will check after adding that optimal solution to the solution set whether it will result in an infeasible solution or not. If it result in an infeasible solution, then this input will not be added to the partial solution set. In this way, it will work and there will be n stages. Okay, it works in this way. Okay, this is the approach we want to use to solve the greedy approach. That is, it works in stages. Each stage consider one input at a time. At each stage, a decision is made regarding particular input is optimal or not. If optimal, if it is an optimal solution, then if it is an optimal solution, then it will be added to the partial solution set. Then next what we will do, if the inclusion of the input into the partially constructed optimal solution result in an infeasible solution, then this input will not be added to the partial solution. Then we check again. Then we check the partially constructed optimal solution. If it is not feasible, then we will remove that solution from this. This is the approach used in greedy approach. This is the greedy approach. And next is the control abstraction. So control abstraction means this is the basic format. For example, divide and conquer, there is a control abstraction. Dynamic programming, we studied a control abstraction. Then in the case of a greedy approach, what should be the control abstraction? This is the control abstraction used here. Here, initially there will be a solution set which is empty. Then for I equal to 1 to n, there are n inputs in this case. We are interested to find out a subset of n that satisfies the constraints and objective function. So we will start from for I equal to 1 to n. These are the stages. Okay. At each stage, what we will do? We will select an input A. We will select an input A. Okay, so select an input from the input cell, and suppose it is stored in X. This selection is based on some optimization criteria. Based on some optimization criteria, we will select an input and suppose it is X. Then what we will do? We will add it to the solution set. Okay, we will add it to the solution set. Then what we will do? Then we will check whether the solution set with X is feasible. If it is feasible, then what we will do? We will add it to the solution set. Union of solution comma X. So I'm repeating one more time what is the approach. What should be the approach is initially there will be a solution set which is infinity. Then we will consider each input at a stage. Okay, there are n stages here. You cannot for I equal to 1 to n means there are n stages. At each stage, what we will do? We will select an input from the input set. Okay, from the input set. Okay, this selection is based on some optimization criteria. Based on some optimization criteria, we will select an input. Then suppose X is the selected input. This select is a function. Okay, there will be a select function. Okay, it will be based on some optimization criteria. Anyway, we select an input. Then what we will do? We will check whether the selected solution, selected input X, okay, the selected input X and the solution together is feasible or not. If it is feasible, what we will do? We will add that solution X to our solution set. Union of solution comma X. Union is a function. Union is an additional function to union 2 set, solution set and individual X. Okay. So in this way, it will perform n stages. In this way, it will perform n stages. Each time an input is selected and works in this way. So at last, what will happen? It will return the final solution. So this is the basic structure of a greedy approach program. It will always follow this basic approach. Okay, so this approach is important, very important. Okay. So now we discussed what type of problems that can be solved using greedy algorithm, and what is greedy approach and what is the control abstraction. Okay, so here the control abstraction, try to understand the control abstraction clearly. Okay, so basically after the solution will be, suppose there are n inputs, then or n path is there, then it will be, what will be the solution? Okay, suppose there are n inputs, then the solution will be a subset of n that satisfies all constraints in the problem, and it should maximize the objective function also. Okay, that will be a solution. Okay, that is the property of a solution. So next we want to discuss knapsack problem. Okay, knapsack problem, and what is knapsack problem, and we want to discuss. So 1 minute. Okay, please give your attendance. After that, I will take class. Akash. ആകാശ് ആബ്സെന്റ് ആണോ? ഫാസ്റ്റായിട്ട് പറയണേ. ആകാശ് 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 ആബ്സെന്റ് ഇടണ്ട. അഭിനവ് അഭിനവ് അഭിനന്ദ് ആകാശ് അഭിനവ് അഭിനന്ദ്. ഓക്കെ, നെക്സ്റ്റ്. ഓക്കെ, അഭിനന്ദ്. നെക്സ്റ്റ് അദ്വൈത്. ഓക്കെ, നെക്സ്റ്റ് ആദർശ്. അനക, അഞ്ജലി. അഖിൽസി ഇപ്പോൾ ആബ്സെന്റ് ആണോ? ഓക്കെ, അഖിൽസി ഇപ്പോൾ. ഓക്കെ, അനുഗ്രഹം. ഓക്കെ, നെക്സ്റ്റ് അതിൽ നിന്നിൽ അതിൽ പി കെ. അബ്ദുൽ ആബ്സെന്റ് ആണോ? അതുൽ പെട്ടെന്ന് അതിനാണെങ്കിൽ അതുൽ ആബ്സെന്റ് ആണോ അതുൽ? ഓക്കെ, നെക്സ്റ്റ് ദേവിക. ഓക്കെ, ദിൽന. ഓക്കെ, മസ്ന, ജസ്ന. മസ്ന പ്രസന്റ് ആണോ? ഓക്കെ, ജസ്ന ഷെറിൻ. ജസ്ന ആബ്സെന്റാ? ഓക്കെ, കാർത്തിക് കീർത്തന. കാർത്തിക് കീർത്തന. ഓക്കെ, നെക്സ്റ്റ് മുഹമ്മദ് സിനാൻ. ഓക്കെ, നെക്സ്റ്റ് ഇജാസ്. ഓക്കെ, നെക്സ്റ്റ് റൈസ, ഖാലിദ്, റസാന, നിഹാല. ഓക്കെ, നേഹ, നഫ. നഫ ആബ്സെന്റ് ആണോ? നഫ, നിതിൻ ബാബു. ഓക്കെ ഓക്കെ, നഫ, റസാന, നിഹാല, റൈസ, ഖാലിദ്. ഓക്കെ, നെക്സ്റ്റ് റിസിൻ. റിസിൻ പ്രസന്റ് ആണോ? ഓക്കെ, റിസിൻ ആബ്സെന്റ് ഇടുന്നുണ്ട്. ഓക്കെ, നെക്സ്റ്റ് സഹല ബി. സഹല ബി. സഹല എൻ. ഓക്കെ, നെക്സ്റ്റ് റോഷൻ. ഓക്കെ, നെക്സ്റ്റ് റിസിൻ ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. നെക്സ്റ്റ് പെട്ടെന്ന് സാരംഗ്, സംഗീത്, ഷാരൂന്, ശ്രദ്ധ. ഓക്കെ, നെക്സ്റ്റ്
പ്രസൻസ്.
നെക്സ്റ്റ് ഓക്കെ ഓക്കെ, ബേബി ശ്രീഷ്മ, വിഷ്ണു, അഞ്ജിത, ഷെറോണ. അഞ്ജിത, ഷെറോണ. ക്രിസ്ത്യൻ ആബ്സെന്റ് ഇട്ടിട്ടുണ്ട്. ക്രിസ്ത്യൻ ആബ്സെന്റ് അല്ല. ഓക്കെ, എനിവേ നമുക്ക് മോഡ്യൂൾ 5 ഗ്രീഡി അൽഗോരിതംസ് ആണ് ഡിസ്കസ് ചെയ്യേണ്ടത്. അപ്പോൾ ഗ്രീഡി അൽഗോരിതംസിൽ ഡിഫറെൻറ്റ് ടൈപ്സ് ഓഫ് ഗ്രീഡി അൽഗോരിതംസ്, ദാറ്റ് ഈസ് പ്രോബ്ലം. അതായത് ഒപ്റ്റിമൈസേഷൻ പ്രോബ്ലംസ് സോൾവ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് ഗ്രീഡി അൽഗോരിതം യൂസ്. ഏതൊക്കെ ടൈപ്പ് ഒപ്റ്റിമൈസേഷൻ പ്രോബ്ലം സോൾവ് ചെയ്യുക, ഏതൊക്കെ ഒപ്റ്റിമൈസേഷൻ പ്രോബ്ലം സോൾവ് ചെയ്യുക, ദീസ് ആർ ദ ഒപ്റ്റിമൈസേഷൻ പ്രോബ്ലംസ്. ആൻഡ് നെക്സ്റ്റ് ഇസ് it is used to solve a particular type of problem. That is, the problem characteristics is there are n inputs and we are required to obtain a subset of n that satisfies some constraints. Okay. That satisfies. അതായത് എന്ത് വേണം നമുക്ക് വേണ്ടതിൽ n ഇൻപുട്സ് ഉണ്ടെങ്കിൽ അതിൻ്റെ ഒരു സബ്സെറ്റ് ഓഫ് n ആണ് കണ്ടുപിടിക്കേണ്ടത്. ഫോർ എക്സാമ്പിൾ 10 പാത്ത് ഉണ്ടെങ്കിൽ അതിലൊരു 7 ബെസ്റ്റ് പാത്ത് കണ്ടുപിടിക്കണം. ഓക്കെ, സോ കൺസെപ്റ്റ് മനസ്സിലാക്കുക. ആൻഡ് വി ആർ റിക്വയർഡ് ടു ഒബ്റ്റെയിൻ എ സബ്സെറ്റ് that satisfies some constraints. Okay. അപ്പോൾ അങ്ങനെ കൺസ്ട്രെയിൻസ് സാറ്റിസ്ഫൈ ചെയ്യുന്ന സൊല്യൂഷൻസിന് എന്ത് പറയും? അങ്ങനെ കൺസ്ട്രെയിൻസ് സാറ്റിസ്ഫൈ ചെയ്യുന്ന ഒരുപാട് സൊല്യൂഷൻസ് ഉണ്ടാവും. അതിനെയാണ് ഫീസിബിൾ സൊല്യൂഷൻ എന്ന് പറയാം. ഓക്കെ. അഡീഷണൽ ആയിട്ട് ബട്ട് ബി ഒപ്റ്റിമൽ സൊല്യൂഷൻ. വാട്ട് ഈസ് എൻ ഒപ്റ്റിമൽ സൊല്യൂഷൻ? അതായത് നമുക്ക് വേണ്ടത് ഒപ്റ്റിമൽ സൊല്യൂഷൻ ആണ്, ഫീസിബിൾ സൊല്യൂഷൻ അല്ല. ഓക്കെ. വാട്ട് ഈസ് എൻ ഒപ്റ്റിമൽ സൊല്യൂഷൻ? ഒപ്റ്റിമൽ സൊല്യൂഷൻ എന്ന് വെച്ചാൽ എന്താണെന്ന് വെച്ചാൽ ഈ ഫീസിബിൾ സൊല്യൂഷനിൽ ഒരു ഒബ്ജക്റ്റീവ്, നമ്മുടെ ഒരു പ്രോബ്ലത്തിൽ എപ്പോഴും ഒരു ഒബ്ജക്റ്റീവ് ഫംഗ്ഷൻ ഉണ്ടാവും, കൺസ്ട്രെയിൻസ് മാത്രമല്ല. ഓക്കെ. അപ്പോൾ ഈ ഒബ്ജക്റ്റീവ് ഫംഗ്ഷനെ മാക്സിമൈസ് ചെയ്യുന്ന അല്ലെങ്കിൽ മിനിമൈസ് ചെയ്യുന്ന ഫീസിബിൾ സൊല്യൂഷനാണ് ഒപ്റ്റിമൽ സൊല്യൂഷൻ. ഈ ടൈപ്പ് പ്രോബ്ലം നമ്മൾ ഗ്രീഡി അപ്രോച്ച് വെച്ച് സോൾവ് ചെയ്യേണ്ടി വരും. ഓക്കെ. നമ്മളിപ്പോൾ TSPന്റെ ഒരു എക്സാമ്പിൾ വെച്ച് ഡിസ്കസ് ചെയ്തു. ഇതാണ് TSP പ്രോബ്ലം. അപ്പോൾ ഇതിലെ കൺസ്ട്രെയിൻ, അപ്പോൾ നിങ്ങളൊരു പ്രോബ്ലം നോക്കിയാൽ അതിൽ രണ്ടെണ്ണം ഉണ്ടാവും, ഒന്ന് കൺസ്ട്രെയിൻറ്റ്, ഒന്ന് ഒബ്ജക്റ്റീവ് ഫംഗ്ഷൻ. ഓക്കെ. അപ്പോൾ കൺസ്ട്രെയിൻറ്റ് ഇവിടെ എന്താണ്? ഇവിടെയുള്ള കൺസ്ട്രെയിൻറ്റ് എന്ന് വെച്ചാൽ സെയിൽസ്മാൻ മസ്റ്റ് ട്രാവൽ ടു ഓൾ സിറ്റീസ് എക്സാക്ട്ലി വൺസ്. എന്താണ് ഒബ്ജക്റ്റീവ് ഫംഗ്ഷൻ? എന്താണ്? ദ ടോട്ടൽ ഡിസ്റ്റൻസ് ട്രാവൽ ഷുഡ് ബി മിനിമം. ഓക്കെ. അപ്പോൾ ഈ രണ്ടും സാറ്റിസ്ഫൈ ചെയ്യുന്ന ഒരു സൊല്യൂഷനായി സൊല്യൂഷൻ. അങ്ങനെയുള്ള ഒരു ഒപ്റ്റിമൽ സൊല്യൂഷൻ കണ്ടുപിടിക്കാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ഇത് യൂസ് ചെയ്യുന്നത്. ഈ അപ്രോച്ച് സ്റ്റേജസ് പറഞ്ഞു, അതിൻ്റെ കൺട്രോൾ അബ്സ്ട്രാക്ഷൻ എന്താണെന്ന് പറഞ്ഞു. ഓക്കെ. നെക്സ്റ്റ് ക്ലാസ്സിൽ കൂടുതൽ ഡിസ്കസ് ചെയ്യാം. നാപ്സാക്ക് പ്രോബ്ലം ഒക്കെ ഡിസ്കസ് ചെയ്യാം. ഓക്കെ. താങ്ക് യു.